Okay, this is Unit 3. We're looking at some examples of Newton's second law. This is on page 5. So example 1, a net force of 15.0 newtons acts on a mass of 4.00 kilograms. Find its acceleration. So remember the formula that we came up with just a little bit up the page. We have acceleration equals the net force divided by the mass. Rearranged, it is the net force equals the mass times the acceleration. So two of the formulas, we'll write them both here. Net force equals mass times acceleration. We're looking for the acceleration, so it is the net force divided by the mass. So we're writing our formula. We are going to put in our numbers. 15.0 newtons. Let's keep the units in here. 15 newtons acting on a mass of 4.00 kilograms. Now you could do this one without a calculator. If it were 16 divided by 4, it'd be 4. This one, 3 3/4 or 3.75. That's something that we could all probably do in our heads, maybe. Now on the topic of units. The units that we have right now are newtons per kilogram. This is not going to be the units for our answer. We have to figure out what do the units need to be. So remember our definition for a newton. It was a kilogram times 1 meter per second squared. So this is the same as saying 1 newton per kilogram. So what we will want to do is kilograms will cancel, and that leaves us with meters per second squared, which is the physics units for acceleration. Excuse me. Number 2, what net force is needed to accelerate a 500 kilogram mass at a rate of 0.300 meters per second per second? Net force is mass times acceleration. We have a mass of 500 kilograms, and it is accelerating at a rate of 0.3 meters per second per second. It is telling us the acceleration here. Meters per second squared. And so we find the net force equals 150, and it's kilograms times meters per second squared, which we know as newtons. We have a new situation arising with units. Before, we could always multiply and divide units to come up with the units for our answer. We can still do these problems if we remember the definition of a newton. 1 kilogram times meters per second squared, based on the formula F equals ma. Net force is the mass times acceleration. But as we add more units, it becomes increasingly difficult to remember all of the definitions. So let's start arranging units in families, and remember to stay in the family. Families or systems of units. So first we have what's sometimes referred to as the MKS system. Distance is the meter. Mass, kilogram. Time is the second. And look, see this? MKS, meters, kilograms, seconds. This is your physics family of units. Meters, kilograms, seconds. Force or weight is in units of newtons. Then there's the CGS system, and this is usually more chemistry related. The centimeter, the gram, second, CGS. In the CGS system, we have a different unit for force or weight. And this unit in the CGS system is known as the dyne. In the USA, we have the FPS system. For distance, it's the foot. For mass, for time, it's the second. And for force or weight, we have the pound. Here's our FPS. The unit for mass in the FPS system is not pounds, that's weight, that's a force. So what is the unit for mass? So we have the metric system, we have the US system. The metric system is almost exclusively used in physics. So let's practice with a simple force equals mass times acceleration chart. So net force equals the mass times the acceleration. So we'll do these without a calculator. So we have 20 newtons and an acceleration of 2 meters per second squared. The mass would be the net force divided by the acceleration, 10 kilograms. Solving for acceleration, we have a net force of 100 newtons, we have a mass of 20 kilograms. Acceleration is the net force divided by the mass, 100 divided by 20, 5 meters per second squared. Looking for the net force when the mass is 6 kilograms and the acceleration is 3 meters per second squared. 6 times 3, 18, and the units are newtons.